The device, it converts the one form of energy to the another form, is known as the engine. And Siri, before that the introduction to the IC engines, some of the slides, the world without the electronics engineers, it will be the look like. And similarly, the without the civil engineers, it may be the like. And the world without the communication engineers, the world without the computer engineer, the final one is the mechanical engineer. The world without the mechanical engineer, it will be the happen like. Okay, so we all of you know the engine is device which convert the one form of energy to the other form, and while converting the energy from the one form to the another form, the efficiency of it can play the vital role, and most of the engines convert the thermal energy to the mechanical work, and they are called as the heat engines we know. And that the heat engines broadly classified into the internal and the external combustion engines. There was a classification of the heat engine, the IC and the external combustion engine, the rotary reciprocating, and the external combustion also the reciprocating and the rotary. And in the internal combustion engines, in the rotary type, the open cycle gas turbine, the Wankel engine, and in the reciprocating, the gasoline, that is the petrol engines and the diesel engine. Similarly, in the external combustion one, the reciprocating engine, the steam engines, and the Stirling engine, and the rotary, that is the steam turbine and the closed cycle gas turbine. So these are the the classification of heat engines. See this one. The examples on the internal combustion and the external combustion engines. The first one is the best example for the diesel engine, and the second one is the Wankel type, the engine. And the external combustion one, that is the boiler or maybe the closed cycle gas turbine, that is the power plant. These are the examples. And see here the few components, especially in the moving parts using in the internal combustion, the engine, that is the piston with the piston pin and maybe the called as the gudgeon pin, and the one more is the crankshaft. We all of you know the purpose of the crankshaft is convert the linear motion to the rotational motion. That is the equivalent for to the rotary motion. Those the construction model of the engine cylinder with the, so observe here the passage of the green color, that is the coolant passage. The cooling water will be the flow through these passages, and this is the inlet manifold and the exhaust manifold with the inlet and the exhaust valves. There was a spark plug, and this area is the combustion chamber, the engine cylinder, the piston and the piston rings, and the piston pin or maybe called as the gudgeon pin. There was the connecting rod and the crankshaft. The connecting rod, the big end is connected to the crankshaft, and the small end is connected to the piston. And we all of you know the cyclic operations and the force of the diesel engine. We already discussed that the cyclic operation, that is the suction or maybe the intake stroke, the compression, the expansion or maybe the power stroke, and the exhaust. So in the intake stroke or maybe the suction stroke, especially for the compression ignition engine, when piston travel from the TDC to the BDC, the inlet valve will be open. At the time, the exhaust valve will be in the closed position. Okay. Only the fresh air will be drawn in the engine cylinder by the pressure difference. And in the second stroke, that is the compression stroke, they both valves are in the closed position, and piston travel from the bottom dead center to the top dead center. So what will be the happen? The pressure and temperature will be the rises. The pressure rises nearly more than the 40, the 45 bar, and the temperature rises nearly 600 to 900 degrees Celsius. And at the end of the compression stroke, the fuel will be injected with help of the injector. Then followed by the useful one, that is the expansion stroke or the power stroke. At the time, both the valves also in the closed position. The piston travel from the TDC to the BDC. And the final one is the exhaust one. At the time, the inlet valve will be closed and the exhaust valve will be open. And the combustion products inside the engine cylinder, it can rushes to the atmosphere through the exhaust manifold via the exhaust valve. So this is the schematic diagram or the pictorial view of the 4-stroke compression ignition, the engine or the diesel engine. So see here, those the suction stroke, and the side given, that is the inlet manifold. The pure air will be the enter in the engine cylinder through the inlet manifold. Okay. While the piston can travel from the TDC to BDC, okay, the suction will be the occurs. And in the second stroke, the piston travel from the bottom dead center to the top dead center. At the time, both the valves are in the closed position. What will be the happen when both the valves are in the closed position? So there is the pressure and temperature will be the rises inside the engine cylinder. At the end of the compression stroke, okay, so the fuel will be injected with help of the fuel injector, and followed by the useful one. And in the last stroke, again the piston travel from the BDC to TDC. At the time, the exhaust valve will be the open, and the combustion products will be the sent to the atmosphere. Okay, so this is the line diagram. We already discussed the difference between the okay, so we already discussed the anyone is there? Only the 13 members out of 34, no? Okay. So coming to the difference, the summary point of view, the 4-stroke, the spark ignition engine and the compression ignition engine. In the spark ignition engine, in the suction stroke, the air fuel mixture will be the entered. So observe the first figure, that is the summary, the 4-stroke, the spark ignition engine. While piston travel from the while the piston travel from the top dead center to the bottom dead center, by the pressure difference, the inside the engine cylinder there is a vacuum will be there, and the inlet valve will be the open. Through the inlet manifold, the air fuel mixture will be the enter to the engine cylinder, and the intake stroke are within the suction stroke. And in the second operation, that is the compression stroke. Again, the piston travel from the BDC to TDC. At the time, both the valves are in the closed position. At the end of the compression stroke, with help of the spark plug, the spark will be initiated, and the combustion will be takes place in the power stroke. And in the last one, again, the piston travel from the BDC to TDC. At the time, the exhaust valve will be open. The combustion products will be sent to the atmosphere through the exhaust manifold. The similar working for the compression ignition engine. Initially in the suction stroke, only the fresh air will be entered, while piston travel from the top dead center to the bottom dead center. And in the second stroke, when the piston travel from the BDC to TDC, at the time both the valves are in the closed position. So what will be the happen? There is the pressure and temperature will be the rises. At the end of the compression stroke, the fuel will be injected, okay, and followed by the expansion one. That is the useful stroke. In stroke, the piston travel from the TDC to the BDC. Again, the fourth stroke is the exhaust stroke. That is again the piston travel from the BDC to the TDC, top dead center. The exhaust valve will be open, and the combustion products will be sent to the atmosphere. The combustion products of the carbon monoxide, the carbon dioxide, the NOx, okay, and the unburned hydrocarbon emissions, the like. Okay, so these are the things we already discussed. That is the war-time diagram for the four-stroke, the spark ignition engine. And this one for the war-time diagram for the four-stroke, the diesel engine. Okay, so see the schematic or maybe the pictorial view of the two-stroke, the diesel engine. In the last class, we already discussed that is the two-stroke, the petrol engine, how it works, with the one difference. That is the instead of the spark plug, there is a fuel injector is there for the two-stroke, the diesel engine. Only there are we all of you know, in the two-stroke engine only there are the two strokes, and there is the four cyclic operations will be the occur. See this one, when the piston in the upward stroke, that is from the BDC to TDC. So here the inlet port will be the open, and the rest of the two ports, that is the exhaust port and the transfer port, they both are in the closed position. The fresh air will be the enter to the engine crankcase. Okay, so notice here, in the diesel engine, the two-stroke or maybe the four-stroke, in the suction or maybe in the upward stroke of the two-stroke one, only the fresh air will be entered. Only the fresh air will be entered to the engine crankcase. And observe here, when piston moving towards the TDC from the bottom dead center, so what will be the happen? Here there is the inside the engine cylinder, in the combustion chamber area, the pressure and temperature will be the rises. When the pressure and temperature will be the rises, at the end of the compression, this fuel will be the injected. The fuel will be the injected with help of the fuel injector in a fine particle nearly 140 to the 160 bar pressure. The such as the high pressure, the fuel will be the injected here, and the combustion will be the takes place, and followed by the downward stroke. When followed by the downward stroke, observe here. First, the transport port will be the open. The fresh air will be there in the crankcase. It will be sent to the engine cylinder through the transport port. And in the previous cyclic operation, there is a combustion products will be there. It will be sent to the exhaust port. Okay. So observe here. To avoid the mixing of the fresh air or maybe the air fuel mixture with the combustion products, we are using especially the design, the pistons for the two-stroke, the spark or the diesel engine, that is the deflector type piston. So this is the shape is the deflector. Observe. And this was the similar operation for the two-stroke, the petrol engine. While the piston they moving towards the upward direction from the BDC to the TDC, the inlet port will be the open, and air fuel mixture will be the enter to the engine crankcase from the carburetor. So in the previous one, in the diesel engine, only the fresh air will be the entered in the engine crankcase through the inlet port, but in the petrol engine, the air fuel mixture will be the enter to the engine crankcase through the inlet, the port, and in this position, both the ports are in the closed position. That is, the transfer port will be the closed, and the exhaust port also will be in the closed position. The same similarly, when piston can reaches towards the top dead center, there is the compression will be the happen, and it can rise the pressure and temperature inside the engine cylinder. At the end of the compression stroke, the spark will be the initiated with help of the spark plug. That is, the spark will be the discharge at the end of the compression stroke, and followed by the useful one, the expansion and the exhaust. This one, those the downward stroke. When piston travel from the TDC to the BDC, the initially first the transport port will be the open. Okay. The air fuel mixture will be the entered to the engine cylinder through the engine crankcase via transport port, and simultaneously the combustion products will be there. It will be sent to the exhaust port. So both the operations will be the happen here. Okay, and remember here, to avoid the mixing of the fresh air fuel mixture with the burn the products, it can be prevented by the deflector type piston. So we see the video, then you got the clear idea. And these are the some comparisons with the CI and the SI engines. Okay, so we go with the one by one. So we all of you know the compression ratio for the diesel engines, nearly the 14 to 22, and for the spark ignition nearly 5 to the 10 or maybe the 6 to 10.